In this video, we'll be solving another Leetcode problem, which is same tree, problem number 100. So, quick agenda. So, we'll first go through the problem. What exactly is the problem? We'll take some more examples, and then we'll discuss solution, how we can solve this problem, and finally we'll code in Python, and we'll see two solutions. One is recursive and another is iterative. So let's start. So the problem states that we are given with root nodes of two binary trees, and they have been referenced by P and Q, and we has to write a function is same tree which returns true if both the trees are identical and false otherwise. Two trees are same if they have same structure and at all the nodes it has same value. So if we compare these two trees, so one is root, they are same, then left child 2 is present in both, and 3 is present in both the right child as right child. Then we take, so that's why these two trees are identical, so our function should return true. In the next example, we see that contents are same 1 2, and this also has 1 2, but the structure is different. Left child is true in the first tree, and for the second tree right child is true, so its left child is null. That's why these two trees are considered different and we should return false in this case. In the third example, tree structure is now identical but the values are different. So we have root 1 and its left child is 2, but in the second tree left child is 1, so we'll break and return false. So this is the problem. We'll see how we can solve this problem. We'll see some approaches. To solve this, let's draw example 1, 2, 3, and draw a similar tree. Let's say 1, 2, and 3. So what we can do is we can go through both the trees taking any technique, BFS, TFS, in order, pre-order, but the situation is we has to follow the same path for both the trees. So we'll compare these two nodes, these are same. Okay, we'll go ahead. We can either go left or right from here, but we has to follow the same path in both the trees. So let's say we go to left. So in this tree also we'll go left, in this tree also we'll go left, and then we'll compare the node which is at the left. So this is also same, we are good. Then we are now end of the tree, then we'll check left, this is none, this is also none, so we are good. We'll again check right, this is also none in both the case, so we are good. So we'll go back and then go back once again to 1, and then go to the right, because we have verified this leg. This turns out to be same. Now we'll go to right and we'll compare the nodes at the right of 1. So this is also same, this is also same, and then we'll compare its left and right child, and then further we cannot go. So this way we followed the same path in both the trees, and then we verified that both the trees are same. We can follow any pattern. We can go DFS. This technique was DFS. We went all the way to the leaf, taking one node in both the trees, and in BFS what we do is we traverse level by level. So we traverse this level in both the tree, then we'll traverse second level in both the tree. So we can take any technique. Let's take another example where tree are not same. So 1, 3, 2, 1, 2, and 3. So here this node is not same. So again we'll start from root, we'll compare, these are same, we'll go to left, we'll compare, this value is 3 and this value is 2. So we'll break from here itself and we'll return false, because we found a node whose values were not same, and we won't go to the right of the 1, because we have already found a node which were not same. And in case where a tree structure itself is different, let's say 1 and 2. So here we'll compare this, and we'll go to the left, we'll see 2 here, and we'll go to left, we see none here, or null node here. So we'll break here, and then will return false. And in case root itself is not same, like let's say we have 5 here and some subtree and 6 here, so we can break even faster there. So that's the explanation. We'll code this using DFS, using recursive approach and an iterative approach. So let's go back to Leetcode. So as we saw, first approach, we can do a recursive walkthrough of this tree, and it should be fairly simple to write the code. It should be a couple of lines only. So the base condition will be if P is none or Q is none, which means that my one of the tree has ended, or both may be ended, and I has to stop the recursion. So stop condition will be return P equal to Q. That's because if my one of tree is none, other should also be none if they are same. Otherwise, they are different. So this condition will evaluate to true if both are none, and it will evaluate to false if one is none and other is not. And another condition will be if q dot val is not equal to p dot val is not equal to q dot val, then in that case return false, because I have seen a value which is not equal. So let's say in this case we'll go left, and we'll see here we have 2 and here we have 1. So it will take care of this difference in the value. And in the end, we have to check both left and right subtree. So we'll do left is same tree, p dot left and q dot left, and we has to check right subtree also. So in that case it will be same tree and p dot right and q dot right, and that's it. We can structure this code a bit, and that should be it. So we are actually traversing the whole tree, and then we are breaking whenever we see nodes in the tree are different. Test cases, submit. This works. So we essentially scanned the whole tree, and then at every step we compared the values. So now we'll talk about the time and space complexity of it. So I'll recommend pause the video and think of what should be the time and space complexity of this algorithm. So let's start. So we are essentially traversing the whole tree, P and Q, but at the same time we are also breaking as soon as possible. Whenever we see a difference in the value, or we see one of the tree is none and other has some value, so the time complexity should be min of m and n, if m is the number of nodes in first tree and n is the number of nodes in second tree. So that should be the time and time complexity. But in worst case, if both the tree are same, it should be we can equate this to order of n, because if let's assume both tree have same number of nodes and they are identical, then in worst case we can say that upper bound should be order of n. And space complexity will also be same, because recursion will take the space whenever we are uh, doing the recursion. It saves the call stack. That's why it takes additional space of order of n. So that's the time and space complexity of this algorithm. So in the second approach, we'll do the same thing, but we'll follow iterative model. So I'll revert this, and we'll take a stack and initialize with the P and Q, which is the root node, and then we'll loop over till my stack has some value, and then we'll take pop out nodes from the stack dot pop, and if my n1 and n2 has some value, then we'll check if n1 dot value, if they are same, n1 dot value and n2 dot value are same, then we'll just append both the left and right sides of n1 and n2 to the stack. N1 dot, this actually is tuple, so n1 dot left and n2 dot left, and we'll append the right childs also. And if my nodes are not equal, n1 or n2, then we'll return false. So this take care of the condition if my one of the node is none and other is not none, or the values are not equal. So both the things will be taken care by this elif. And if both are none, then we don't have to do anything. So it won't go into the if or in elif. So we don't have to do anything if my n1 and n2 both are none. So while appending, we are not checking if they are none or not. So that's why we has to skip if they have been into the stack. And if we come out of the loop, which means that we were able to see each and every value were same, and both the tree were same, so it should be true. Let's run this. Accepted, submit. This also got accepted. So this is essentially the same thing that we did in the first solution. It's just that we are doing the same using stack. We are maintaining our own stack instead of using Python stack. So time and space complexity for this algorithm remains the same. So in this case also time remains order of n, and space also is order of n. That's because we are taking this space and we are looping over till my stack is not empty. That's why time and space complexity of this is order of n. So thanks for watching. See you in the next one. Bye.